All right, folks, we are now going to be looking at increasing and decreasing functions in our 1.5 section that we're in. So definitions are going to be based off of how the function behaves as we go from left to right. So that's the big thing we want to keep in mind. So a function f is increasing on an interval when for any x1 and x2 in the interval, x1 less than x2, so basically again we're going from left to right, implies that the y values increase as well. So as you go from left to right, the y values increase as well. So you can kind of think of that as going uphill. So uphill. All right, and now decreasing, you can probably guess pretty quick. So again, we're going from left to right still. And now the y values get smaller. So now you're going downhill as you go from left to right. And then the third case is the constant case. So when you move from left to right, you're not moving up or down at all. So obviously you're going straight across. So if we wanted to determine open intervals on the function on which the function is increasing, decreasing, or constant. So looking at this first one, you can see as we work from left to right, it is going uphill. And it keeps going uphill until it gets to this point right in the middle. Now, the important thing that we care about with increasing and decreasing is the x values, not the y values. So what x values is this function increasing on? And so starting at x equal to -2, it stops increasing when it gets to x equal to +2. So that's what we would write. And because we don't want to include those endpoints, because at the endpoints it gets a little messy, we'll just leave those out. So we'll use parentheses. So we can say -2 to 2. Would be the increasing interval. And so once we get to 2 and start going further to the right, we can now see we're going downhill. So it's decreasing and it stops there. So the x values would start at 2 and end at 6. So 2 to 6. And again, we don't want to include those endpoints because it's a little so-so. It's hard to say at a specific point if it's increasing or decreasing. Now, let's look at the other one that looks a little bit more interesting. So, again, working from left to right. Don't let this arrow down here, throw you off or anything. All we care about is if we're going from left to right, what's going on. So, we're going uphill until we get to this point here. So, increasing, but because this is an arrowhead, that means it goes forever to the left. So it's going to hit every x value to the left. So from -infinity all the way to this x value here, -2, it's increasing. And then from there on, once we get to 2, it stops. So between -2 and 2, it's not going up or down, so it's constant. And that's it. So those ones can be pretty quick as long as you have a diagram. If you don't have a diagram, you might have to draw one. So, all right, let's see what's on the next page. That's the wrong page. Let's try. This page. Yeah, good. We got a couple more that we can do. So what do you think about C? What are the intervals for increasing, decreasing, and constant? And hopefully you're saying, well, it doesn't look like it's doing very much except for increasing. And because of the arrowheads means it's doing it forever. So increasing would be from -infinity to infinity. Nothing else is going on. All right. So increasing. what would be the interval for increasing on this one? So you can kind of see right in the middle, it's going uphill as we go from left to right. So the x values are 1 to 2. And again, don't include those. All right, what about decreasing? Well, it's going down on the front part of it. So again, looking at the x values, -2 all the way to 1. And then finally constant. Well, right in here, right between these two, so from 2 to 5. All right. So those ones are pretty nice. You just got to be careful. Think of it in terms of the x's, not the y's. The y's are not important for increasing, decreasing, just the x's. All right. Let's try one more, and then we'll call this video good. So determine the piecewise function that yields the following graph. Identify the function where the function is increasing, decreasing, or constant. Okay, that part's the easy part. Let's do the first part. We have to actually develop what that function is. Now, the first thing we notice is that there's two behaviors going on. One of them is a line going off this way, and one of them is a line going off this way. So it looks like there's two branches that we need to keep in mind. Now, before we worry about the domains on those branches, let's just try to identify the functions. So let's start with this first one here that's going downhill. So we know it's a line. Now, if we were to draw the whole thing out, what would be the equation of it? That's what you have to ask yourself. Now, remember, if we want a line, all we need is the slope and the y-intercept. So, can you tell me what the slope of that line is? If we're going from here, we can go over 1 and down 1. Over 1, down 1. So it looks like the slope is -1. But the y-intercept, if we kept going that pathway, it would pass right through the origin. So the y-intercept is 0. So it looks like we just have a -1x, or just a negative x for the first branch. Again, don't worry about the domain restrictions yet. So what about this line? What's the equation of that line? Well, up 1 over 1, up 1 over 1. So we can see that that one has a positive 1 slope, but what's the y-intercept? It crosses at -1. So it looks like this should be x minus 1. So now we have the behavior, but we got to restrict it using our domain. So where does it change? What value of x does this change at? And you can kind of see we have this overlap here at -1. So -1 is the critical number. We want to change things around. So x is behaving like this, or excuse me, the function is behaving like this when x is smaller than -1. So x is going to be less than -1. Now, here's another important question. Do we want it strictly less than, or do we want it less than or equal to? And that goes back to looking at the graph. We have an open dot here, which means that -1 doesn't behave like this function at that spot. So we would not want the equals, the less than or equal to. It's got to be strictly less than. So on this branch, now we do have a solid dot, so we do want to include it. And it's everything to the right, so we want it to be greater than or equal to negative 1. And there's our piecewise function. And so increasing, decreasing, constant, we can kind of see there's nothing constant going on, so we just have the increasing and the decreasing. So what would be those intervals? Well, we can see that it's decreasing, again, all the way to negative infinity, but it stops at negative 1. And again, we don't want to include it, so negative infinity to negative 1, and then it's increasing all the way to the right forever, and it's going to start doing it at x equals negative 1, and we don't want to include that there either. And so that should be our intervals. All right, we're almost done with this section. We got a little bit more to do. We got some average rate of change stuff, which we've talked about, so we'll see that in the next video. Stay tuned.